A very good morning, everyone. Okay, so we are going to start with today's lecture. So let me briefly tell you what we did in the previous lecture. So we started with Laplace transform and we introduced first shifting theorem, also known as first shifting property. So what was this first shifting property? That if you know Laplace transform of a particular function, then if you multiply that function with e raised to power ax, then it is going to transform your answer like this. So P will be changed to P minus A. So this is in short, I'm telling you, and we have already done questions for this one. So now we are moving to second shifting theorem, or this is also known as, or you can just say, let me just move to the next page. This is the property number 2 or theorem number 2. So in this, what we are going to do is basically differentiate differentiation of Laplace transform. So you should know that if I am saying L of fx is fp, then this is known as Laplace transform of fx. This operator is known as Laplace operator, and the answer which we get is known as Laplace transform. So the final answer. So differentiation of Laplace transform, or it is also remembered by the name multiplication of fx by x. So I gave you few examples last time, that suppose you are able to find Laplace transform of say this, right? So we will be able to do this with the shifting property, that first you find Laplace transform of sine 3x, and then using this result you can get your answer. But what if you get questions like x cos x? So you know that already the Laplace transform of cosine x, but what happens if you multiply this with x? So this does not come in the category of standard formulas. So this kind of examples will be covered here. What happens when you multiply your fx, small fx with x, what happens to the Laplace transform? So I'm skipping the formal statement, that all is the complete statement is in the book. I'm just going to tell you the result which is going to use in the question, because rest of the things are same, that assume that functions Laplace transform exist, it is a piecewise continuous function and exponential order, so all those things. So I'm directly telling you the result. So this is minus d by dp of f of p. So you already have this information. This is given to you, that Laplace transform of fx is fp. So what happens when you multiply with x on the left hand side? It's not on the left hand side. When you multiply with x to your function fx, then you have to differentiate your Laplace transform and multiply it with a negative sign. So for the shifting property, I gave you a small proof because the proof was just by the definition. But for this one, the proof is little lengthier. So we are going to skip that. I'm not giving you the proof of this in case you are interested. So you can read from the book. So I am just going to use this in the questions and tell you how it is going to be used. And there is a general, even more general formula when you multiply with x raised to power n. So it's clearly, when you multiply with x raised to power n, that means it is equivalent to multiply x n times. So that means n times you have to differentiate, because when you are multiplying with x raised to power 1, so you are differentiating one time. So when you will be further multiplying with one more x, you will be again differentiating with respect to p, and negative negative will become plus, right? You can say from this formula that L of x square fx is going to be, so you already know x into fx is minus d by dp. So this will be minus d by dp of d by dp of fp, and 1 minus is already there. So this will give you d2 by dp2 of fp. So that means on multiplication with x square, you take the second derivative. Similarly, you can say on multiplication with x cube, it will be the third order derivative, but again a negative sign will come. So the negative sign will be alternatively coming and going. So for odd order derivatives, so or you can say for odd powers, it will be there, and for even powers, it will not be there. So this gives you the general formula will be minus 1 raised to power n dn by dpn of fp. So whatsoever power you are multiplying, that many times you differentiate your Laplace transform, and that power you need to multiply minus 1 raised to power n. So if you remember this one, so this is automatically covered in this. So this is true obviously for all n, 1, 2, 3, and so on. Okay, so let's do examples for the same. So the first example is find Laplace transform of, say your function is x cos 3x. I'm moving to last slide. Somebody wants to note down. So this is the main formula you need to remember, which will be used in the questions. Right? So let's apply this to this question. You have to find Laplace transform of this. So very first thing, by looking at the function, you have to now identify that which theorem or which property you will be using here. Now you already know Laplace transform of cos 3x. So what is Laplace transform of cos 3x? This is p over p square plus 9. So what is going to be Laplace transform of x cos 3x? So according to this property number 2, this is going to be, because you are multiplying with 1 time, x raised to power 1. So this is minus 1 raised to power 1 time derivative of p over p square plus 9. So whatever is the Laplace transform, this is our f of p, right? Function of p. This one you have to differentiate with respect to p. So it's easy now. All what you have to do is find the derivative. So I'm writing the answer so you can verify that yourself. So it's p square minus 9 over p square plus 9 whole square. So that's very easy. So this part will be like obviously depending upon how much difficult or the easy function is, but you just know the formula, and now you just differentiate and simplify it to up to certain extent, and you're going to get your answer. So that's all about this. So further, if I ask you what is going to be L of x square cos 3x, so L of x square cos 3x is going to be minus 1 raised to power 2 d2 by dp2 of p over p square plus 9. So it's 2 times you have to differentiate this fp and then multiply with 1 plus 1, right? So it will be, or you can say one more step you go ahead, and then there will be another negative sign coming out. So you can do that yourself. So as many times x will be multiplied, so it's just going to lead you to finding more and more derivatives. Yeah, so this is all about this question. Let's do very quickly the next example. Say you have to find Laplace transform of x cube e raised to power minus 4x, right? So this is what I need to find. So this question can be done in two ways. The first way is, you already know Laplace transform of x cube. Yes, please write your answers. What is the Laplace transform of x cube? I will be solving this question in two ways to give you the idea that there will be many examples which can be done alternatively by more than one method. So I'm giving you both of them for this particular example. So I notice this is my function. So I'm firstly finding L of x cube. So what is x cube? We know the formula is L of x raised to power n is n factorial over p raised to power n plus 1. So this is 3 factorial over p raised to power 4. And now if you look at your function, this is e raised to power minus 4x times x cube. So you can use now shifting theorem. So using first shifting theorem, L of e raised to power minus 4x x cube. Yes, what it is going to be p plus 4 raised to power 4, because whatever the answer turns out to be, e raised to power ax is there, so p is changed to p minus a. So it's minus 4, so its p is changed to p plus 4 now. So this is the answer of using first method. And using second method, you will be first finding this e raised to power minus 4x. So what is Laplace transform of e raised to power minus 4x? It is 1 over p plus 4, because we know that definition. Laplace transform of e raised to power x is 1 over p minus a. So now you will be multiplying with x cube. So when you will be multiplying with x cube, so you will be using the property number 2. That means what happens when you multiply with x raised to power n. So in that case, you have to write it's minus 1 raised to power 3, 3 times derivative of which function? 1 over p plus 4. So you differentiate this 1 over p plus 4 3 times and then multiply with the minus 1. So you will be getting this answer. It should match. It's not going to be like with one property you are getting a different answer, with another you are getting a different answer. It will be going to be same. It may happen in some examples that it may seem to you that the answers are different, but they are not going to be. Essentially they may be in different form, but it should be same. So you can verify this. So there will be questions like this where it will be your choice, whatever clicks to you first, that which particular property is helping you out in getting the answer. There is absolutely no condition that you have to do by this way only or by that way only, right? So this was easy. I'm moving ahead towards the next example. Right. So the next example, we are going to find Laplace transform of gx is equal to x e raised to power minus 3x sine 2x. So what is the difference, how this function is different from the previous two examples or any examples done so far? This is a product of, you can say, three functions: x, e raised to power minus 3x and sine 2x. So yes, this is a question to all of you. Can you suggest how we are going to do this? Anybody can raise hand and answer for this one. What do you think how this will be done? Okay, yes, Arman.
मैम फर्स्ट पहले फर्स्ट शिफ्टिंग आएंगे देन सेकंड शिफ्टिंग आएंगे.
Okay, yeah, so the order is immaterial. आप पहले second बाद में first भी लगा सकते हो. It's up to you, right? So there is because product है, we do not differentiate. This can also be written like e raised to power minus 3x x sine 2x. So it's clearly up to you. आप पहले first लगाना चाहते हो या बाद में second? It's up to you. But usually we prefer हम जो ये वाली shifting property है first वाली, वो सबसे last में use करें, because you know it's very easy to implement. क्योंकि जो भी आंसर होगा जस्ट p को रिप्लेस करना है p माइनस 3 से या p प्लस 3 से यहाँ पे, राइट? सो अदरवाइज डजंट मैटर. आप पहले फर्स्ट शिफ्टिंग यूज कर सकते हो, बाद में मल्टीप्लिकेशन वाली प्रॉपर्टी. But I'm going to do it like first I will be using the multiplication with x property and then I will be using the shifting one. Right. So firstly, okay, thank you, Arman, for your answer. So L of sine 2x. So everybody knows L of sine 2x. So this is 2 by p square by plus 4. So we know the formula of sine ax is a over p square plus a square. And then what is L of x sine 2x? So on multiplication with x, you have to differentiate one time and multiply with a negative sign. So I'm writing that directly. You can verify this later that this is going to be your answer. 4p over p square plus 4 whole square. And now finally, e raised to power minus 3x x sine 2x. So we know the shifting is to be done. This is minus 3. So p will be changed to p minus minus 3. That is p plus 3. So this is 4 times p plus 3. 3 plus 3 whole square plus 4 whole square. that is your answer, right? So you can now try the other way yourself, that first you do the shifting. This is complete as an answer. You can try this way, that first you do as a shifting. So when we will be first doing shifting, so here we'll be having 2 over p plus 3 square plus 4, and now you differentiate or by multiplication with x. So answer is going to be same. It depends upon how you simplify. If you open up the squares here first, then your calculations is going to be little bit lengthier. But if you don't open up the square, you want to keep it like this, so it will take altogether another way. But the answer, final answer, is definitely going to be same. Okay, yes, Pranshu, you have a doubt, you can raise your hand. Pranshu Goyal, do you have a doubt? Okay, this is the previous slide. Somebody wants to see. Okay, so yeah, that's all about this example. And then we have gx, and this question is done. So you can see with the help of this question that it can be done in many ways, the same question, and you can have even more complicated examples where all what you have to do is to optimally decide that how you're going to see the properties, how you're going to use the properties. And then there are few questions, I'm not going to solve them completely, very easily you can solve them yourself. So like I'll give you, say, x cos hyperbolic 3x. So this will be also done. So for so one thing you can do here is, this can also be done in two ways, right? uh, One is you can use directly the formula of cos hyperbolic 3x. What is Laplace transform of cosine hyperbolic 3x? What is Laplace transform of cosine hyperbolic 3x? Yes. So we have the general formula for cosine hyperbolic, that is p over p square minus 9. And then when you are going to do this one, so you use the property multiplication, and so you have to differentiate minus d by dp over p square minus 9. But other way you can do it, like you can use the formula of cos 3x. Cos 3x is e raised to power 3x plus e raised to power minus 3x by 2. So this can be, because linearity. So here also, now it's easy, you can see x e raised to power 3x plus 1 by 2 L of x e raised to power minus 3x. So already know L of x. Here also will be doing shifting. Here also will be doing shifting. So it will be 1 by 2. What is L of x? L of x is 1 by p square. It will be 1 by p square, and shifting done will be 1 by p minus 3 whole square, and this will be 1 by p plus 3 whole square. So now you simplify, and this one, they will be same. So it's just what clicks to your mind. And this technique of cosine hyperbolic or sine hyperbolic breaking into exponentials, you can use anywhere, in case you do not, say, somehow forget or do not remember the standard formula for hyperbolic. So depends upon what is used where and how do you get it. I'm just giving you these examples to tell you that do not get confused if you do it with other technique. Okay, let me give you the previous slide. You are asking for this. Yes, please ask if you have any doubt so far, because we are done with the these kind of questions. After that, I'll move to the next property number 3. Anybody has any doubt so far in property number 1 or property number 2? Yes.
मैम मैम जो प्रॉपर्टी नंबर 2 थी मैम, उसमें आपने लिखा था डिफरेंशियल ऑफ लाप्लेस ट्रांसफॉर्म। मैम
Yes.
तो मैम अगर डिफरेंशिएट कैसे करेंगे हम इसके अंदर?
डिफरेंशिएशन इसको बोला जा रहा है, यू सी, दिस इज डिफरेंशिएशन। इसको लैपलेस ट्रांसफॉर्म बोला जाता है ना, जो कैपिटल एफ एज एन आंसर हम लिखते हैं, वी से दिस कैपिटल एफ फंक्शन इज अ लैपलेस ट्रांसफॉर्म ऑफ, ये जो हम स्टेटमेंट लिखते हैं हम लिखते हैं फाइंड लैपलेस ट्रांसफॉर्म ऑफ स्मॉल एफ एक्स, सो एक्चुअली वी आर लुकिंग फॉर कैपिटल एफ, सो कैपिटल एफ इज नथिंग बट द लैपलेस ट्रांसफॉर्म। सो इस प्रॉपर्टी को मतलब ये याद रखने का तरीका है, आई विल टेल यू दैट व्हाई इट इज कॉल्ड बाय लाइक दिस। सो एक्चुअली इट्स मल्टीप्लीकेशन ऑफ एफ एक्स बाय एक्स, बिकॉज हमारे पास ओरिजिनली ये फंक्शन है और उसका लैपलेस ट्रांसफॉर्म पता होता है। So why this is given this name? This is because of the right hand side. So if you want to understand this same statement, from the perspective of small f function, so we remember it like, okay, what happens when you multiply small f with x, or we say what happens when you differentiate the Laplace transform. I will connect it when we will be studying inverse Laplace transform, right? Because after this few properties more left of this, we will introduce inverse Laplace transform. So every property you are using for Laplace will be equivalent for inverse Laplace, because you just have to take inverse to both the side, this L will go to this side. So that's why you try to connect that differentiation of one thing is equivalent to the multiplication of x on the other side. Is that clear? So this is
Yes.
derivative is for this one, not for this. हम फर्दर L का कोई डेरिवेटिव नहीं कर रहे हैं, जो ऑलरेडी F हमारे पास है हम उसी को डिफरेंशिएट कर रहे हैं.
Okay, ma'am.
Okay, so Pranshu, you are asking property 1. This is property 1. It's very simple. Okay, now I'm going to move ahead with the property number 3. So property 1 we multiplied with exponential, property 2 we multiplied with x. So in property number 3 we are going to divide with x. So this is division of fx by x. So L of fx by x is equal to, so we already know that is the standard thing given to us, that this is given, we know the Laplace transform of small f, that is capital Fp. So what is the Laplace transform of fx by x? So this is, yeah, this is going to be, any guesses for it, what it is going to be? If multiplication was differentiation, so the division would be integration, right? So that's how we remember it. So division is equivalent to integrate. So it's p to infinity fp t p. There is no negative sign involved here. So means these are the ways to remember. Okay, multiply करते हैं fx को x से, तो right hand side पे हमें differentiate करना होता है, but वहाँ पे negative sign introduce होता है. और डिवीजन करते हैं x से तो हमें इंटीग्रेट करना होता है. अब सेम फॉर्मूला को आप जनरलाइज भी कर सकते हो. सपोज हम इसको एक्स स्क्वायर से डिवाइड करेंगे, सो इसको दो पार्ट्स में सॉल्व करना पड़ेगा, राइट? सो पहले हम करेंगे से gx by x, where gx will be fx by x. ऑलरेडी gx में एक x इन्वॉल्व है. So we know that what that is going to be. So it will be like 2 times integral of the same function, because first division with x will introduce one integral, and again again divide with x will introduce another integral. So this is also generalizable, right? So here also you will be doing integration 2 times if you divide with x square. But you will see as such you will not see the written anywhere in the books, because nth order derivative को denote करने के लिए तो हम we have a very precise notation, but n times integral करने के लिए we do not have a precise notation. That's why they do not write it like this, but essentially it means the same. कि अगर x square से divide है तो आपको 2 बारी integral करना पड़ेगा, x cube से divide है तो 3 बारी, but they are very rare examples जिनमें आपको इतनी बार इंटीग्रल करना पड़े. So most of the times it will be just one times division with x, but still generalizable. So let me give you the formula for the questions for the same. So find Laplace transform of fx is 1 minus cos 2x by x. So clearly you see your function is like, okay, in which we have in the denominator. So far whatever functions examples we have done, there was no denominator present. All functions were just the like without any fraction term there. So when you see it's divided with x, so immediately you remember property number 3, that okay, firstly we will be finding Laplace transform of the function in the numerator, and then we will be using the property division with x. Okay, so firstly I will be finding L of 1 minus cos 2x, and L of 1 minus cos 2x, because of the linearity, because Laplace transform is a linear operator, I can use that. So L of 1 is 1 by p, and L of cos 2x is p over p square plus a square. So 2 square is 4. So this is how, this is your capital FP. Now here it's your choice. You want to simplify it at this stage, or you just want to keep it like this. Because if it would have been the final answer, you can leave it here, or you can simplify it a bit. But you see what is the next step coming. The next step is division with x. So immediately you see, okay, I have to integrate the right hand side. So it would be better you keep it as simple as possible. So the Laplace transform of 1 minus cos 2x by x is integral of, remember the limits, it's from p to infinity. So whatever is your f of p. So this you have to integrate. So now it is easy. So the first term 1 by p dp, the integral will be log p, and what is going to be the integral of, so we have to obviously substitute the limits. What is going to be integral of this? So you can multiply and divide with 2. So so this will be 2p 1 by 2. So the derivative 2p is there. So it's log of p square plus 4, and obviously the limits p to infinity you have to substitute. And so if you substitute limits like this, you will get indeterminate form, infinity minus infinity. So better you first simplify and then you apply the limit. So it will be log p over square root p square plus 4. Is this clear to everyone? Because this half, will go to the power of this using the properties of log. So, and then there's a log a minus log b, log a by b. So I have used that property. This is now you have to solve. So now if you will be substituting upper limit and lower limit, so then you will be getting, the answer will be, so what is the answer of the upper limit? Because the upper limit is basically, let me write here. It is limit p goes to infinity log of p over square root p square plus 4 minus, the lower limit is just p only. So whatever is the function, it will be just like that. So usually this is going to happen because one of the limits is going to be just p only. So there is actually no substitution for that, for the lower limit. It's just the upper limit you have to evaluate. So upper limit when you will be evaluating, so you will see it will be infinity by infinity form. So but we have to divide by p to get it this. So it will be 1 plus 4 by p square minus log p by square root p square by 4. And now you take limit p goes to infinity just in the first term. The second term is without the limit. So this will be log 1 by 1 because this part will go to 0. 4 by p square will go to 0 when p go to infinity. So log 1 is 0. So this is minus log p over square root p square plus 4. That is your answer. You want to write one more step simplified. So it will be log p, just take the denominator, right? The final answer is log square root p square by 4 by p. That's it. This is your final answer. So again, in these questions, you see, it's not difficult to apply the formula. The difficult part, or you can say the calculation part, will come when you have to integrate. So depending upon how your function is, it may take a lengthy calculation to get you the final answer. But this is the technique, that how you recognize. So with all these questions we are doing, it's important to learn the technique in your mind, that how we are going to recognize. Because in the question they will not tell you use first property, second property, or third property. You have to decide it yourself with having all the information in your mind, that this property will be used for solving this particular question. Is that clear to everyone? Yes, now I'm moving towards the next example. So the next example is, show that 0 to infinity e raised to power minus x cos 3x minus cos 2x by x dx is half log 1 by 2. So this is a different kind of question. You see, the statement is not find the Laplace transform of a particular function. They are not asking us to find Laplace transform. So you might be surprised, okay, this question does not involve anywhere the Laplace transform, but you see carefully the left hand side. So what this left hand side is, we have to solve the left hand side and automatically prove it to be right hand side. So let's first analyze what is there on left hand side. So if you carefully look at the definition of Laplace transform of any function, what is the original definition? So 0 to infinity e raised to power minus px fx dx, right? You know, this is the definition. So if you compare now these two, what is given to you here, this integral and this integral. So if you compare these two, so that means if I take fx as cos 3x minus cos 2x by x, if I'm going to find Laplace transform of this function, if I take fx like this, then I will be getting this integral as an answer. Finding Laplace transform of fx, where fx is this, will give me the value of the integral L of, just a minute, cos 3x minus cos 2x by x. I'm putting the value of fx now. This will give me e raised to power minus px cos 3x minus cos 2x by x dx. Is that clear? I just use the definition of Laplace transform for this function. I've not solved it so far. I've just substituted the value of f. Now you see that what you need to evaluate is this integral. And what I have is this integral, because I will be able to solve the left hand side. I know the techniques to solve the left hand side. So whatever the left hand side will be, it will be the value of this integral. So how will you relate this integral which you need to find and the integral which you have to find, which you will be finding eventually? So what is the comparison? This term is same. Here, if you see, it's e raised to power minus x. Here it is e raised to power minus px. So that means whatever be the answer for this, I will be in the end putting p is equal to 1, because on putting p is equal to 1, I will exactly get the value of this integral, and this will be, you will see, this itself will turn out to be equal to half log 1 by 2. Because whenever we evaluate Laplace transform, all our answers, you see, so far we have done so many questions, all our answers are coming in terms of p is a parameter. So now this is a question of different kind. We have to find Laplace transform only, but carefully look at that, okay, what is the value of p to be substituted. So this is just cleverly given question, that they are asking you to find this is equivalent to say that find Laplace transform of this function and then put p is equal to 1. So the question is split into two steps. This is step number 1, this is step number 2. So you will find these kind of questions there in the book and tutorial sheet, that this is how you have to do. So let's first do this. So now I'm interested in finding Laplace transform of cos 3x minus cos 2x by x. So for that, I know which property is going to be used. Yes, yeah, okay, Shan is having a doubt. I will explain again. Yeah, so I'm going to explain that if I take fx as this function, then I get this expression by definition of Laplace transform. So I will be able to solve Laplace transform using the formulas I know, and that will be a function of p. And I need to evaluate this integral. So this integral is same as this integral. The difference is p is here, but p is not here. So that means this integral can be obtained from this integral by putting p is equal to 1. So the final answer of this Laplace transform of this function, if I'll be putting p is equal to 1, I will get the value of this integral uh, after putting p is equal to 1, and which will be same as this, and it should be same as this because we have to show that this is this. So let me just go with this. L of cos 3x minus L of cos 2x by x. So this we will divide in again further two steps. Firstly, I'll be finding for the numerator, because the moment you see, okay, it's divided with x, So you first have to solve it just for the numerator. And for the numerator, so I know the formula of L of cosine 3x. So this is p over p square plus 9, and using the property of linearity, cosine 2x, it is this. So it's just subtraction of these two. So this is your function. This is just optional. You may not write this is capital FP or something. All what you need, this is your answer. Okay, and now I need to find, sorry, this is 3x minus cos 2x by x. So division with x is equivalent to do the integration from p to infinity. So p over p square plus 9 minus p over p square plus 4 dp, obviously integrating with respect to p because there is no other variable. So it's easy now. It's 1 by 2 log p square plus 9, because to solve this integral you'll multiply and divide by 2, so 2p will be there and same is here, minus 1 by 2 log p square plus 4. This is the limit. So it's basically 1 by 2 you can keep outside. Now you just look at your function, the final answer has to be 1 by 2 something, so this 1 by 2 you can keep outside. So 1 by 2 log p square plus 9 by p square plus 4, and now you have to substitute the upper and lower limit. So what is the answer of upper limit? Can anybody tell? It will be like, because when you will be dividing with p square, right? So it will be 1 by 2 log 1 plus 9 by p square 1 plus 4 by p square minus 1 by 2 log. For the second you just need not do any simplification, that's just keep in terms of p. For the upper limit, because you have to put the limit p going to infinity, so I have to make expressions like 1 by p 1 by p square. So this terms will go to 0 in the first. Let me write on next page. So this is limit p going to infinity half log 1 plus 9 by p square 1 plus 4 by p square, and the second term is retained as such. So this goes to log 1 because this is 0 0 as p goes to infinity. So this is half log 1 minus half log p square plus 9 over p square plus 4. So the first term is 0. So this is minus half log p square plus 9 over p square plus 4. So this is Laplace transform of cos 3x minus cos 2x by x, which is the integral 0 to infinity e raised to power minus 3x cos 3x. So this is what we have evaluated. What you need to evaluate is the same integral, but p was given to be 1 there. E raised to power minus x hai yahan pe. So what you have to do is, in the expression on the right hand side, put p is equal to 1. So when you put p is equal to 1, so it's 10 by 5. So that is log 2. So the answer is minus half log 2. So this is half log 1 by 2. So the negative is adjusted with the log property. That's what you wanted to prove. 1 by 2 log 1 by 2. Is that clear to everyone? Anybody has any doubt so far? Okay, yes, Yuvraj, you have a doubt? Can please raise your hand? I've already explained from where p is equal to 1 is coming. It is coming because you wanted to find the value of this integral. From there p is equal to 1 is coming, right? So the same question, if I change the same question, the same statement, I give you a here e raised to power minus 2x. So you will repeat the same calculation, but in the last you will put p is equal to 2, right? Because in general it is e raised to power minus px, so it's e raised to power minus 2x if I'm asking, so we will be putting p equals to 2. But for this question, this was just e raised to power minus x. Obviously then answers will change on the right hand side on putting p is equal to 2, but whatever it is, you have to do that, right? So this was division with x. So differentiation and multiplication is done, and division, which is also called integration, that is also done. And now we have the, you can say, more questions to practice for the same kind. So I'm going to give you that. So you can practice these questions on the similar lines. Show that x e raised to power minus 2x cos x dx is 3 by 25. So how you are going to solve this question? So this is same like, because on the left hand side you see the Laplace transform of x cos 2x, sorry, x cos x. The Laplace transform of x cos x is going to be 0 to infinity e raised to power minus px x cos x dx. So this integral is same as this integral. It is just you have to here put p is equal to 2. So when you put p is equal to 2, it will give you the value of this integral. So you have to find a Laplace transform of this function and put p is equal to 2, you will get this automatically. So that's how you have to relate in these kind of questions. Okay, so this is done, and now we are moving towards the next topic. So these are the properties which you can use and solve various kind of questions using these combinations of properties. So next we are going to introduce is inverse Laplace transform. So inverse Laplace transform, it clearly means you already know what is Laplace transform. So if I'm going to use the same statement, the formal definition is the same. It will also have certain conditions for the existence of Laplace transform. So we'll talk about those conditions later. So right now I'm just telling you that if L of fx is fp, then L inverse of fp is small fx. So it's very easy to understand. Laplace transform of a function small f is capital F. So the Laplace inverse transform of capital F function is going to be small f. It's the similar like the derivative of one function. It's similar like if we know that d by dx of fx is gx, then we know that integral of gx is fx. Roughly, we know that on integration we get the constant, but this is one of the solution for that. So same is here. If f has a Laplace transform capital F, so the Laplace inverse of this is going to be the small f. So that is the definition of inverse Laplace transform. So formulas for it. So you will be obviously happy to know that you don't need to remember any new formulas for the same, because if you already know the formulas for Laplace transform, so you just immediately can derive the formulas for inverses from there. So the first formula which I gave you for Laplace transform, what was L of 1? 1 by P. So it implies L inverse of 1 by P is going to be 1. Right? And second, L of, what was L of x? L of x was 1 by p square. So this implies L inverse of 1 by p square is x. And similarly, we know that L of x raised to power n, that was n factorial by p raised to power n plus 1. So L inverse of 1 by p raised to power n plus 1 is going to be x raised to power n by n factorial. So this, how this is done, that firstly I will be writing L inverse of n factorial by p raised to power n plus 1 will be x raised to power n, and then I will be dividing with n factorial, so it will be this one. So you will be finding questions like this, so you can directly use this one. Okay, yes, Vidushi, you're asking how we are getting these formulas. These are the same formulas we already know for Laplace transform. We know the definition of Laplace transform, right? So the definition of Laplace transform of a function, the basic definition is this. We already know this is the definition, and using this definition we have certain formulas. We already know Laplace transform of 1 is this, we already know Laplace transform of x is this, and Laplace transform of x raised to power n is this when n is a positive integer. So as per this rule, that if Laplace transform of a function is capital F, so it makes sense to say what is the inverse Laplace transform of this function, right? So it's same thing like if e raised to power x is some function, then what is the inverse of exponential function is a logarithmic function. Exponential and logarithmic function, they are inverses of each other, right? So just shift the sides. And so that's why I said that you don't need to remember any new formulas for inverse Laplace transform. It will be how much you use, you will be automatically start remembering them if you know the formulas for the Laplace transform. And for Laplace transform also, if you forget any formula at any moment of time, then you know the definition. You can always integrate and derive the formula yourself. So this is for positive integer. So the next formula is for, say, L of, we know, x raised to power n is gamma n plus 1 over p raised to power n plus 1, where we know n is any real number except the negative integers, and obviously 0 is also not allowed, n is non-zero, n is greater than -1. So in that case also this will be happening. So L inverse of 1 over p raised to power n plus 1 is x raised to power n by gamma n plus 1 whenever n is satisfying this. So like a very quick question, say find L inverse of 2p plus 5 over p square plus 25, right? So you see immediately, okay, because now when you will be finding Laplace inverses, so you will be given a function of p, because you will be given capital F, you will be supposed to find small f this time, because the question is now reverse. So we have to find Laplace inverse Laplace transform of this one. So this is in notation. So it's easy because and one more property we know, the Laplace transform is linear and inverse Laplace transform is also linear, so you can break down into the additive terms. So this is going to be L inverse 2p over p square plus 25 plus L inverse 5 over p square plus 25. So this I can write, this 2 can come outside. So this is L inverse of p over p square plus 5 square, and this is L inverse of 5 over p square plus 5 square. So which formula you need to remember from here, which formula it reminds you? We know that L of sine, what is L of sine AX? A over p square plus a square. And what is L of cos AX? It is p over p square plus a square, right? So from here you can see this one will be 2 cos 5x and this one will be sine 5x, because this is a over p square plus a square is like this, where a is 5. So this is Laplace of sine 5x. So inverse of this will be sine 5x. So same is here. This is 2 is separate, but that is the answer. Okay, so that's all for today. We are done with time. I'll take your rest of the doubts in the next class. Tomorrow we do not have a class. Tomorrow morning we do not have a class because now the number of lectures has been reduced. So our Wednesday class will not be there. I'll be taking your lecture on Thursday. Okay, thank you. That's all for today.